Okay, hi and welcome to Note 6.7. We're going to talk about graphing absolute value equations. And in doing that, we're going to introduce you to a nice new topic called the Vertex Form, which is, I think, officially your first introduction to it. So let's get right down to it. This is kind of a backwards way to do it. I'm going to show you all the gists and all the points and things that make up graphing absolute values and using the vertex form. I'll show you what it looks like, and then tomorrow we'll do an activity with it. So we're going to kind of work backwards into this. So let's get into it. An absolute value function, if you remember from our family of functions activity, is that of a v. Okay, so when we graph it, it looks like a V. I think we're all okay and familiar with that. The point that converges where it changes direction, we like to call that the actual vertex. I'm going to label that on here because I don't know where that comes up. Vertex. I'm going to go ahead and label it now. That's that little point right there. Okay, so what we're going to do with this is we're going to use this vertex form here to move it around. Okay, and that's all going to be based off of its parent function. And I know I'm jumping around these notes, but you can read them and write them down. What we're going to do is we're going to translate this vertex, or this parent form, this very basic of all absolute values. And we'll use the idea of vertex form repeatedly. We'll use the idea of a parent function repeatedly. Every function that we talk about this year has a parent function. Okay, and then we're going to shift that vertex around this point here. We're going to move it all around the coordinate plane. And when we do that, we can figure out the way it's going to move if it's written in this vertex form. So it actually is a really nice, easy form for you to do, but you have to become familiar with it. Once you're familiar with it, you'll actually like it quite a bit. The reason we do that is because we're going to always be looking for its solutions, and we know that that's where these functions cross the x-axis. So that part you're familiar with. So let's review what this vertex form looks like. If this is the parent function, the simplest of all absolute values, it's got an x and an absolute value sign. There's nothing added, subtracted, or multiplied to it. We can shift that vertex around. We like to identify the x-coordinate as h and the y-coordinate as k. So if we shift it around or we put something inside the absolute value, that moves it left and right. And the funny part is, in this vertex form, there's supposed to be a negative here, and we've become familiar with that with point slope form, so that when we plug in an h, if it looks positive, it's actually going to go to the left, and if it looks a negative, it's going to go to the right. So this value that's inside the absolute value sign is going to move it to the left if it's positive, to the right if it's a negative. Now the outside value, or y value, it starts out as a positive, so it's going to do what it looks like it's going to do. So if it's positive, it's going to go up. If it's negative, it goes down. So if there's something added to the outside of the absolute value sign, positive moves it up, negative moves it down. All right, so now that we've got an idea of what the vertex form looks like, let's go ahead and talk about a pattern. Now, I'm going to say this a lot. Why do we need a pattern? Because all parent functions have a really simple pattern that can be duplicated. So here's our parent function for the absolute value. Y equals the absolute value of x. This is the simplest of all absolute values. And if we just take values of x, like -3, and we plug it into the absolute value, if we recall what an absolute value does, it takes away any negative numbers, because all we're concerned with is looking for distances. So we don't care about negatives, and positives stay positives. So -3 inside of this function, if I plug -3 in here, it becomes +3. And if I plug -2 inside the absolute value, I get the absolute value of -2. It becomes 2. So what you'll see quickly is all the negatives become positive, all the non-negative numbers stay the same. And that pattern is pretty simple. Okay, -3 becomes +3. -2 becomes +2. If you can memorize this pattern, you can graph with the vertex form really easily, because you can graph that parent function wherever that new vertex goes. So let's graph this one really quickly. Let me grab a little bit darker of a one. I'm going to zoom in here so we can see it. So I'm graphing the parent function, the very simple function that you're going to memorize this pattern. It doesn't matter it's at the origin right now. We're going to memorize the pattern. The pattern goes like this. Identify the vertex. I don't know if you can see that. It's right here. Right? That's where the numbers repeat themselves on the y, going away from it. So right here in the center is 0, 0. Then I'm going to go right one, up one, right one, up one, right one, up one, right one, up one. See how easy that pattern is? Right one, up one. I mean, if you want to talk about it, -6 goes in the absolute value, +6 comes out. Now the other side is the negative side. We're going to go left one, up one, left one, up one, left one, up one. Let's check it. If I plug in -4 into the absolute value, I get +4 out. So you can see this is a really simple pattern to repeat. Let me go ahead and draw some lines in here for it. That one right there should work pretty good. And then you get your absolute value function, your V-shaped absolute value function, by repeating that simple pattern. And the simple pattern, let's just repeat it, for this parent function with, there is a little cheat here, there's no value multiplied to the absolute value, and you won't see that this time, so we'll worry about that later. But if there's no value in front, the pattern is right one, up one. Okay, left one, down, up one. Ooh, almost wrote that the wrong way. That's the general pattern. Do you need to memorize that? Sure. It's just this X and Y table right here. You can duplicate it in your head because it's easy enough to do, but you'll want to become familiar with it. Now, once you know it, what you're going to do here is you're going to look at these functions here. So here's an absolute value function. Notice it's not the parent function. We have a -4 there. See, that would be the parent function. Y equals the absolute value of x. But we just said we have to become familiar with that absolute, or the vertex form. And the vertex form, let me duplicate it right here. Y equals the absolute value of -x minus h, or positive x minus h plus k. Okay, so what that means is if there's a value inside the absolute value sign, it moves it left and right. And if there's a value on the outside of the absolute value, it moves it up and down. So first thing we're going to do is we're going to identify the movement of this. And we said that the k, if it was standard form, or standard, it positive went up and negative went down. This is on the outside of the absolute value. So this means that this 4 is going down. So our vertex is going down 4. Okay, so let's go ahead and graph that. Here's how this works. You ready? We're going to put it all together. Maybe all spinning around your head, but here's where it goes to make sense. All we have to do is identify what's happening with our vertex. We're going down 4. I'm going to go down 4. Guess where my vertex is at? Right there. There's no left and right movement because there's nothing on the inside of the absolute value. I have something on the outside. It's negative, so I go down 4. So this black line is our parent function. Y equals the absolute value of x. We're going to take this same pattern. All we're going to do is scoot it down 4. And then we're going to make the same pattern. Remember that pattern we just learned? Up 1, right 1, up 1, right 1, up 1, right 1. That's that pattern. Up 1, left 1, up 1, left 1, up 1, left 1. Yeah, that pattern right there. That's the only pattern we need. That is graphing with the absolute value using vertex form. So you can see here that I'm going to draw these lines in, and we've got our new function. Should have probably done that in the color that it was, but that's okay. So there's my blue one. I'll change to orange now this time. So here's my orange one. This is going to be the second one we're going to graph here. Now you'll notice that there's nothing on the outside of the absolute value, so we're not going up and down. This time we're going on the inside. And on the inside, remember, it's a little bit tricky because positive goes to the left and negative goes to the right. So if we look at this, it says -2, so that means we're going to go to the right 2. Here's my original. I'm going to go 1, 2. So there's my vertex. No up and down movement because there's nothing on the outside. Then I repeat that pattern. There, right there, up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. Okay, and then I'm going to go ahead and draw in. I'll get that black color again, and I will get my line, and I will draw that line in. And so you can see, even though it sounded crazy when I went through all this, it's a pretty easy process if you can remember that simple pattern. So what we did is we just graphed 2 on there, and you can see the parent function, the original. So all we're doing is moving that vertex around and repeating that pattern. So find the new vertex, then repeat that pattern. That's your job. So let's look at number 3. On number 3, you can see we've got 2 movements. Let me grab a new color here. So we've got 2 movements. We got something on the outside of the absolute value, right? And we said that was positive goes up, negative goes down. We can see that. Oops, I kind of lost my vertex form. There it is. Positive goes up, negative goes down. This is a -5, so we're going to go down -5 for our vertex. But additionally, we have a value inside the absolute value. And we said that positive, as tricky as it was, is the one that's going to go to the left. So this one's going to go down 5, but it's also going to go left 2. So we're going to take that vertex, which started here in the middle, right? That would be our parent function to start right out the origin, 0, 0. And we're going to move it left 2, down 5. So that new vertex is going to go here. So check, we just found the new vertex. Now we repeat that same pattern that we had. Up 1, right 1, up 1, right 1, up 1, right 1. Up 1, left 1, up 1, left 1, up 1, left 1. Nothing to it. Let's graph our line. And there is your graphed absolute value. You can, let me repeat this, you can plug in points here. Right? You could make, and this is always true, you could make an x and y table and pick some values of x that are negative and positive. Right? Plug those in and find out the y. It's going to take you longer. It's a little bit more work, but it will still make these same exact points. But this, if you get that pattern and you understand what these two movements are of h and k, it's pretty easy. Just a little bit of practice. So I'm going to end the notes here, but two things to remember. One, what this looks like. This is your vertex form. So remember vertex form, right? Remember that's a negative there. Remember it's supposed to look opposite. And remember what the two values do. H is the tricky one. Positive goes left, negative goes right. K is the one that's familiar. Positive goes up, negative goes down. If you can remember those two things, you're great for graphing. All right, that's the end of the notes. We'll see you in class for an activity.